Hi, I'm Indranil Chakraborty. I'm the product manager leading our IoT Edge and Edge ML platform. What we have here at IoT Solutions World Congress is really showcasing our end-to-end platform for IoT solution. So we have Cloud IoT Core, which is a managed service for customers and partners to connect millions of devices at scale globally to Google Cloud, so they can easily ingest data in a secure way and then use our downstream data storage, analytics, and machine learning service to get key business insights from the data they collect. And we've also announced recently our Edge platform, which entails Cloud IoT Edge, which is a runtime which can run on the device to extend the cloud data analytics and machine learning services onto the device. And we've also announced ASIC, a hardware Google designed ASIC chip called Edge TPU to execute machine learning model on the device itself. So Google Cloud today is the only cloud provider which offers an integrated hardware and software stack for machine learning in the cloud as well as at edge. And what we have here is a showcase of all our partners who have been building really compelling applications for Industry 4.0 in manufacturing space, in the parking space, in oil and gas, using our end-to-end Cloud IoT platform, which entails the Cloud IoT Edge, IoT Core, and rest of Google Cloud services to build a compelling application. And Google Cloud is really committed to work with our partners to build up the partner ecosystem for IoT. So we are really excited to be here, and we can't wait to see what our partners and customers build using our platform.
Hi, I'm Thomas Watling. Welcome to the Deloitte stand at IoT Solutions World Congress. We're showcasing here, it's a bit of a marketing demo really. We did some work with a client out in the US. We helped them sort of digitize their factories, so collecting data on machines they'd never collected data before, doing the analytics to look at efficiency of those machines. So they were a company that looked at sort of liquids and chemical production, and they had challenges around consistency of mixtures and how that impacted the efficiency of their processes. So we helped them on that, and then we started looking, and I know it's a bit of a buzzword, but actually at sort of maintenance downtime, how you optimize that schedule, and fundamentally it's predictive maintenance. And then finally really the health and safety of the workers in that space and how you can communicate to those workers when they do positive things and when they do negative things in your whole process. And it's quite an exciting concept to talk about, and we found people sometimes need, I guess, a bit of help imagining what that future looks like and how they can get there. So we built this augmented reality demo, low battery at minute, but it's on the App Store. It's called sort of Virtual Factory by Deloitte, and you have a target image. It uses PTC's Vuforia platform, and you can tour around the factory. You can see the use cases we did in that instance, and you can read more about it. And there's a few sort of hidden Easter eggs. And then I guess for the rest of our stand, Deloitte is a broad organisation, and for us IoT is not this narrow sensor hardware platform analytics piece. Actually, it's just digital. It's the internet. You know, digital used to be this big. People have done multi-year digital transformation programs, and they've got to be what they thought was the edge. And actually, Internet of Things has simply grown that. Digital is more pervasive. It is in more places, and so we need to help people take the characteristics of digital, be it that always on, that customer centricity, that data-driven analytics, that ever-evolving, that ability to do prototyping, that ability to experiment. We need to take that and we need to do it more. We need to do it more in factories, in industrial settings where there's a different risk profile. We need to do it in commercial spaces like airports and retail and conferences themselves. And really it's about helping clients understand that digital has grown. And hopefully on our stand we've embodied that a bit. We've got cameras from a startup doing flow analytics around our stands. We know the number of people who visited, we know where they visited, we can compare that to last year when we did the same. We've got emotion sensing cameras on a game, so we take the ducks and we've got a bit of a game going on, seeing if we've been exciting people. And we've got another camera that's looking at people who are engaging with content there. Their gaze detection with our content, so we know what content was successful, what content maybe should be improved for tomorrow at the conference, and that's our stand.
Hello, my name is Jörg Thompson. I'm Market Validation Director at PTC from the United States. On our booth here at the testbed at the IoT World Congress, we're showing our Industry 4.0 demonstrator. With the software of PTC, you are able to connect new machines, old machines, getting all the data out of sensors and PLCs with our industrial connectivity platform to leverage all the advantages of Industry 4.0. We're using the data to do predictive analytics and also showing OEE KPIs to production manager. On top of our solutions, we also have augmented reality solution, which fulfills some Industry 4.0 purposes. We deliver standard applications that makes it easy to implement and use and leverage all the data coming from the machine. Here we can see the demonstrator, which has around about 80 sensors delivering 800 data points per second. So much data for this small part of an assembly line. We start from the assembly process over quality management and get all the data from it. As I said, we have the different applications, and as a production manager, I may be interested in how our manufacturing line is doing. So I'm just looking at it, choose the line, and we have all the key figures that are necessary for a production manager to rate how the line is doing, how much products will be produced, and how much good products are produced. And on top of it, as I said, we have the augmented reality solution. So if we come over here and we scan this code, now what we have seen now is everything is on premise, but we have a hybrid system here. So now we're going into the cloud and getting data out of the cloud. We can see all the key figures are augmented on the system. So I don't need a device to have it. I can also use a HoloLens or a head-mounted device. If I want to see some information about some special things, I can maybe look to the compressor and see the values, so the humidity and the temperature of the compressor. And you see on the quality station we have a problem, so we have an exclamation mark. That means there is an alert running on that system. So I click on it, and now we get some 3D CAD data from a PLM system and some warnings. And in the background you see the vibration is too high because we have a failed bearing. So now I can say, okay, can you show me how to replace the bearing? Now the second warning comes up because it says unless it's not switched off, I'm not allowed to work on it. So I just push the play button, and now you can see how this will be replaced. Which tool should I use? Then take out the bearing, bring it back, and then fix the bearing again, and then put the belt back on. All those informations helps our customer to gain really the advantage of Industry 4.0 purposes.
Good afternoon, my name is Ricardo. I'm Global VP for Telit Factory Solutions. Telit's a global company traded in London Stock Exchange, and in 2013 Telit acquired part of IBM Industrial Automation Group, one spin-off called ILS Technology. And here to the show we are bringing some of our Industry 4.0 solutions. Our Industry 4.0 software is called DeviceWise. DeviceWise is one software that is used in many industries, specifically in automotive industry, lots of implementations in pharmaceutical and many other segments. DeviceWise provides the ability for companies to collect data from literally any type of PLC, DCS, DC2, CNC, sensors, whatever is the physical machine that they are using on the shop floor. DeviceWise can collect this data in an automatic way using native drivers. It has more than 100 native drivers available at the platform. We can treat and transform all this data, publishing this data in different types of enterprise systems like SAP, Oracle, different types of cognitive bases. And one interesting product that we are bringing here to the show is one legacy gateway that we call the Atom Box that allows companies to collect data from even extremely old machines like CNCs or whatever machine that has more than 20, 30 years that doesn't even have one Ethernet port, but with external instrumentation we can collect data from this type of devices that are still in use, and we can integrate with all the different types of systems that the companies are using in the IT sector.
So here on this stand booth we show you the complete process for building a production line. So that starts from the very beginning when you start the layout. Then we show how you do the access. Let me go to this side here. You do the access programming, of this line, all on the virtual model. You do the operation, the programming of it, and use the testing, the real behavior testing of this line, even before the first screw, and you even touch the hardware for that. Then on the next process, we do the optimization for this line in terms of really model calibration, which is exactly supposed to be really exactly the behavior of the machine. Then we do the monitoring of the line through the complete process, where we find, and if we find the deviations in terms of behavior of the machine, we can take corrective actions. So let me start here. Just showing you with the layout. We're starting with the layout of the machine. So actually, what we do, you look at going to what we call the marketplace, part supply marketplace, where you look for elements. For example, here from Bosch Rexroth, that you can configure online with different parameters on it. So you look for the right equipment to build the mechanical layout, and rather than only importing CAD model, what we show here is that you insert it directly into the CAD system with all the behavior modeling behind it. So it's not only the PDF file and the step file, you really insert it directly into CATIA V6 with all kinematics predefined, with Modelica libraries that define it for the further usage. Let's go a little bit ahead. So you create your different elements of the line. Accelerate a little bit. And you position your line with the different elements into the factory, right on the layout plan. So you see, we have the one that we just defined. Okay, go forward. And now we build the complete line here on this layout. So we attach the different modules that we have for the line. So you have the robot module, you have a module where you do the housing, you do a screwing, you have a roboter module, we have a laser module, etc. So we fit it together, creates a line layout in several steps, and then do what I just said before. We do the details on the access programming, the behavior, and how the machine, the components, the different modules work together. So that's really getting there. So you define, it's not only kinematics again, but you prepare for programming of the complete line, the behavior of the line, and you test it, how these different components work together. So what we're doing here as well, so we have the different components. So you have the layers, you have the modules that we put together. Now we are really going into the programming of the complete line with product control build, where you test the logic of the machine, how you get it really together to make sure that it works in the end. So every single position. What is the important thing here is that based on the 3D Experience platform, we really have all the data that we created on the 3D Experience platform. It's not only the CAD data that we started, but the complete process. We just jumped into the complete process of building a line. You have in the system, on the platform, within one data model, you have the 3D, you have the requirements, you have the functional description, you have the logical description, and the physics behind it. So coming from here, As well, you use it for creating the line, so we prepare everything in the virtual environment to make sure that it works when you really start getting the line together. So what we're working on is in the next steps here, that we couldn't show it here, is to do the auto programmation of the PLCs of the line, so that the code is automatically generated from these virtual definitions. We do even more. We have the sensor data. So with the sensor data, in this example, we work very close together with Bosch Rexroth as an example, and Bosch Rexroth has a device called IoT Gateway. The IoT Gateway is there to collect the information, all the sensor data on real time, to filter the data, to secure the communication with a data lake, which could be Azure, which could be any other cloud-based systems. And to make sure that all this information really is available. And what we do here in the first step, before the hardware, we create digital data of the sensor data from the simulation. So you are capable of comparing this first virtually created sensor data later with the real data. So that's very important as well. So that means that we will have the possibility, once the line is operating, to always compare and monitor. And if you find derivations of the system, then we can look and dig into more detail. How do we do that again? So we have another product called Exhibitors. So Exhibitors is monitoring on this part as well the possibilities of. Sorry. Thank you. So from here with Exhibitors, we are doing analysis on the sensor data in the data lake to identify the issue. So because we have possibilities to see there is a derivation from the sensor, but we have to take corrective measures. So that means from here we really start and say, with this we help dig with Exhibitors into the sensor data, identify all the information, and use the different information coming from all different systems. So the sensor data, the development data, the manufacturing data, the production data, whatever it is, where is it installed, which customer has what installed, to make sure that we can take the right decision to take these corrective actions. And then once we do these actions again, we go back and do in the virtual model, we have the corrections we apply the correction in an engineering change to the system and make sure that the line and the virtual model are always in sync. That's what I personally call digital twin. Not as very often we're talking in the industry about the digital twin, meaning that we collect sensor data and build up the virtual reality afterward. For me, this is just a virtual mirror. So we are really talking about the virtual twin here in this case. So we can go into much more detail about every single step of this, but I think from a first level, the high level overview, if you have questions, please don't hesitate asking them.
Hello, welcome to our flexible and manufacturing with predictive maintenance experience. What we're showing you today is a full experience that we've done in Dassault system through the experience platform. We're starting by grabbing the data from our machines, from our IoT sensors, using our Delmia Priso software. We also use and work with our OSIsoft partner to grab the data. So the challenges here are how to capture the data, how to store the data, and how to analyze the data. Once done, of course, we can monitor the operations and the machines within Apriso Delmia. And we will, within the same platform, we will have the capability to learn more and to predict the new failures. And now in the story, I'm showing this Exhibitors machine learning and predictive analytics. What we are doing, we are using the big data. We are using all the data coming from the platform and coming from our other softwares to predict the future failures. Because we are using one single 3D experience platform, we will, once we predict a new failure, we will give a task to our colleagues within the platform, within Delmia or Temps, to schedule and to execute an action. So please come with me, I will show you here one application which is called the manufacturing analytics application. So the purpose of this application is to help the user as, let's say, I'm the factory's manager. I will need a tool, a smart tool, to predict the failures and help me having an action. So here you can find on the left is the list of all the predicted future failures. Let me first explain how we can have this kind of view. Of course, we need to have a lot of data. Here for this experience, we were working on 79 machines in six factories in the world. So of course we have a small, at the beginning, analytics, KPIs, capabilities, which will enable us to drill down and to analyze better our factories. So here I'm filtering on one factory called Transmission Equipment Shanghai. I want to have a better view on all my analytics and KPIs within this factory. Here I can see the major KPIs, the overall equipment efficiency, the performance, the quality. I will continue to analyze, I will to drill down on the work center which have the lowest efficiency ever. And I can see within this KPI that this one is the lowest. So what we can see now is we selected the work center which have those 3 machines which we have a decreasing efficiency. Because we are historizing the data, of course we can compare the efficiency before and the efficiency now. So once we have that, I will move to my detailed view about each machine to understand better how it's working. So here I'm zooming on one machine called 5-ax machine, and here the magic will start happening because we're grabbing the data from everywhere. So we're grabbing the data from our appraisal tool, which is the tool which enables us to monitor the operations and the maintenance. So we have here some events, the setup, running, downtime, etc. Better than that, we have some graphs which will show us the real-time data coming from the sensors, from the machines. In the red, we will have the old failures that we have in the past months, years, decades. And in the green, because we have a big data factory and we can use our machine learning algorithms to learn from those failures, we are using the deep learning to give a fingerprint to each failure and to predict the future failures. So what you are seeing here is an example. We are predicting a new failure that will happen now. Because we are using one 3D experience platform, we can use the virtual world and combine it to the real world. So here what you are seeing in the blue is the data coming from the simulation world, and in red you will see the real world coming from the sensor. So it will enable us to have more detailed views to compare the virtual and the real world. So as a facility manager, I want to understand better this prediction. I will click on it. I will have more details about those predictions. So of course I'm predicting a new failure, but better than that, I will recommend some action for my users, because we are giving some fingerprints to each failure. So we will help the user to have the similar old failures, and we will recommend one action to our operators. So let me give you maybe 2 takeaways. First, we are using one single platform, which is the 3D experience platform. We have a digital continuity within all our workers, the designers, engineers, manufacturers, operators. So we are learning and we are also closing the loop. So we are learning from the real world and putting all the information into the virtual world. And because we're starting combining the virtual and the real world, we are ameliorating our products each day.
Hello, welcome on the IoT Solutions World Congress. My name is Jim ten Broeke. I'm Business Development Manager in Advantech. As you can see here on our booth on the show, we are showing what we are doing as Advantech in the IoT world. together with our partners. Advanter is a global developer and provider from embedded platforms, data acquisition and infrastructure, based in Taiwan, producing in China and Taiwan our platforms. As you can see behind me, there's the strategy wall we are showing here, where you can see that we are connecting to the sensors in IoT and over trusted platforms going up to the applications. Together with partners, we are developing solutions which bring the end solution to the customer. So with a partner network, we are addressing multiple applications in multiple market segments. We call it co-creation. We are doing it for a longer time now, working together with partners and combining domain expertise to bring the best values to the customer. So that's what Advanter is doing.
What we are showing here is a very simplified model and how we can integrate OT technology, which is currently used on the shop floor, into our IoT platform. So therefore we have picked these devices and machines which are available in the current shop floor, like sensors and machine, a motor, and field gateway and PLC, which is controlling everything. So the setup we are having here is a very simplified model of a PCB router, which is part of an SMT production line. And this machine is cutting these PCBs into different pieces, and this is usually the last step of this SMT production line. So what we are doing right now is that we've added an IoT gateway to this setup, which is communicating with the PLC. So on this PLC is running an OPC array server, and we are now able to get all the data which is available in the PLC and transmit it to our platform. So what it's worth, or why are we doing this? So this sensor, for example, is generating an event and saying, okay, something is there, and the PLC says, okay, motor turn in the other direction. And we are using this information in our platform and enriching it with process knowledge. So we know every time this event occurs, we have cut it one of these bigger boards into 8 pieces, and now we have a real-time insight into our production by just using data which is available and use it in another context. And this can be shown here. So now we have a real-time insight into our production, so how many parts have been produced today. We've integrated, at least simulated here in this showcase, the connectivity to a testing model, so we can also identify how many scrap has been produced, and we have so the operator of this machine can directly see how is my production going on, what's the quality I'm currently producing, and we also have, using this information, we can provide predictive maintenance information, giving him an indication when has to be the next maintenance taking place, and all this by just using the information which is there already, just by adding some gateways and connecting these devices to our platform.
We provide security for the industrial IoT, and we work with a couple of companies and kind of research centers such as Aachen in Germany and AMRC Factory 2050 in the UK. And I think one of the key parts to this is of course securing the data and also authentication, protecting the IoT platform. So for example, if you have a number of devices connecting into your platform, it's really important that you have the authentication mechanisms in place so that the IoT platform can basically check, with the devices connecting in, that they are the legitimate devices. And to do that, we have obviously authentication technology in place that we leverage on devices that automates the process of getting keys, not stored on the devices, but kind of decentralized into a platform. And what Device Authority delivers is a key scaler platform that keeps all the keys, and that we leverage then to sign pieces of data that the device is then used to authenticate into the platform. And that kind of gives you both end-to-end encryption and also strong authentication. And you basically protect the data, and you also protect the IoT platform. And that's basically what the core strength of the Keyscaler security solution.
Hi everyone, you're at the Eurotech booth here at the IoT Solutions World Congress. We are showcasing a Industry 4.0 use case here, where we actually demonstrate how simple it would be with our hardware and software offering to connect to your factory floor machines, your production machine, extract the data from the machines, do edge analytics and aggregation of the data into the cloud. When you are approaching an Industry 4.0 problem, you have machines that have data inside, whether it's diagnostic data or operational data. And your problem and your challenge is extracting that data, access that data both on the edge as well as in the cloud. You can actually do that through retrofitting the existing machines, right? We understand that the production life cycle of those machines can be up to 40 years. Replacing those machines with new machines with connectivity is a problem. So a possible solution to that is retrofitting with gateways. So gateways are ruggedized embedded computer boxes, rich in I/O. They actually interface with the machine. They're actually able to talk the field protocols of the machine, to understand the language of the machine, to extract that data, and they provide connectivity towards the cloud. So whether it's through cellular modem or Ethernet, depending on each of the use cases. What makes us different is that as Eurotech, we have a wide range of gateways for very different verticals, whether it's just industrial or transportation. So the same gateway applies on a bus, for example, or a train, or actually a light tram. And each of these different verticals have different certifications. So our family of gateways are ready to be deployed in those verticals. They come pre-certified and with all the connectivity options. Not only you can deploy them and reliably operate them, you have a software that runs on this gateway that simplifies the acquisition of the data points, the acquisition of the data sources, the edge processing, so be able to aggregate, filter, and do some analytics on the edge, as well as the publishing into the cloud. We can do one quick demonstration, maybe if you come with me. We have a demo showcase here, so it's a simplified version of an industry factory floor plant. The breakout board simulates what it is a machine. The machine is connected to a PLC. The PLC actually extracts the data through Modbus. Modbus is a typical industrial use case protocol to interface with the machines. And then this is one of our gateways. So the gateway has software. Our software that runs on the gateway is called ESF. It's a disk layer. It simplifies the data acquisition from the edge, the processing, and the publishing to the cloud. So with this software, you can actually model your data sources, create a digital twin of your object, and then publish it into the cloud. We can see it here. So I'm actually now connected into the gateway, and in the gateway I've actually built visually, without writing a single line of code, a data pipeline that on a periodic basis it actually connects to the PLC, extract the data and the status point, which I have modeled through a visual programming tool. So for each of the data points I created a name, I give it a direction, whether it's read or write or only write, and a type. And once the data is acquired, it can actually be published into the cloud, or I can build actually some edge analytics pipelines that can, for example, monitor for thresholds or do aggregation points and publish to different cloud providers. So as a simple way, for example, you can see how I can actually not only read the data, but I can actuate it. So from here, through my model, let's say that I actually want to turn one of my LED off. I will actually change its current value from true to false and publish it. And I operate and I actually reflect the change over there. All these changes are available locally from the gateway or through the cloud, into our secure cloud platform. So that's a very quick introduction of what we offer. There are proven building blocks that let you quickly deploy on the floor, get the data, and actually start improving the efficiency of your operations.
This is the Telefonica in-house developed IoT platform. This is a multi-purpose platform. It covers all the main requests for every different IoT industry. What we have here is real-time control and supervision of the SIM cards that are deployed in the IoT solution. So we here when we say SIM cards, we refer to cellular SIM cards, 2G, 3G, 4G, also narrowband IoT and LTE category M. What we can do here is gather a lot of different information regarding consumption, expense, location, presence information, and also device information, and any issue regarding connectivity. We have a whole set of alarms linked to rules, automatic rules, so we can not just notify by different methods, traps, SNMP traps, SMS, email, but also we can configure automatic rules. So, for example, you can disable a SIM card if it is moved from the location that it should be, or you can also disable the services or the SIM card in case the SIM moves from one device to another. How do we know it? Because of the email number, because the network provides the email. Okay. We also have a whole set of reports, so you can download in CSV format, for example, all the information regarding presence-based, subscription-based, consumption, expense, location, presence information, accesses to the platform by API, by web portal, and a lot of different things. We provide all this information through API, so you can integrate these capabilities with the application you develop. We also provide a secure link to the main public clouds, for example Azure, also Amazon Web Services and Google. And we have some dashboards that also makes easier for the customer to detect issues, both technical and security issues. For example, if you detect any anomaly in the behavior of the SIMs or the connectivities. Finally, you have a whole set of user profiles, so you can, you as a customer, you can inside your company provide different users with different roles and profiles to every department of your business. So everyone has access only to the information that he has to do. And the more important thing is that all is real time, or we can check here, for example, how we can perform diagnosis. So you can see there is a problem in the GPRS attached, not in the HLR, things like that. And you have a lot of information regarding consumption and expense and location, all in real time.
I'm Guillermo from Equion, a partner of Vodafone. We have a solution for the industry 4.0, and we have a hardware and software solution. It can monitorize energy and industrial variables. We have a part hardware and a part cloud. This is the equipment to monitorize energetic variables and ambiental variables, and we can integrate the PLCs or the machines into the cloud, so as software as a service. In the platform, you can see all the variables in a lot of kinds of times. Okay. In this industry, we are monitoring 6 services and 28 points controlling. We have electricity, gas, comfort, and phones. You have a menu with control, electricity, gas, comfort, external variables of the atmosphere, equipment, analytics service, project service to show the saves from the baseline and adjust to put the commercials commercial cost and the schedules, our calendar, or a lot of variables of the people that are working at the industry. The platform, the software, it has a first screen which shows the consume the consume of the last days from October, the cost in euros, maximeter, the power maximeter electricity, and the cost of the last month. You can see all the points monitoring actives. Then in the top of the screen it shows the menu of electricity service: energy, power, cost, tension, intensity, PU for CPDs, electricity cost of the Spanish continuous market, and the electric balance of the footprint or the carbon footprint. Then, if you go into the consume electricity, you can see the shares of electricity in the temporal range. We shows the last week, and you can choose the temporally days if you want. If we choose a normal week, we show the general electricity counter of the submetering. You can change all the submetering that we are monitoring, and it shows in the platform if you put the cursor in the graphic, you can see all the power consumption in any time. Okay, this is a dynamic graphic that shows in any moment the consume from the first to the last. You can export the image in a lot of kind of formats, or export in Excel. You can create an incident, a note, or event on this point, and you can show in a table the consumption of the submetterings. It's an industry that works the aluminium, that it has heating process, and you can see in control SCADA in real time. In these boxes, you can see the consumption, the power maximeter in the last quarter minutes, and in live you can see the plant map with the power consumption of the last 15 minutes. This is an SCADA, and we shows in pink the three variables: temperature, humidity, fluxes. In orange, the gas consumption, and in green, the power consumption in electricity. We have also gas, comfort, equipment, analytics, and this platform made to the industry saves for 8 or 10% per year.
Today here at IoT Solutions World Congress, Orange Business Services brought a lot of solutions that can be interesting for the factories to enhance Industry 4.0 and with very precise solutions, such as outdoor asset tracking all the elements, the pallets, the goods that are coming inside the factory. Indoor asset tracking, just behind me, where we can track objects, tools, bodies that are being built with a precision of around 20 centimeters in 3 dimensions, and that's really important to quickly find tools, save up to 1 hour per day per worker, but also model all the building process from all this information. You can know what's really happening without having to scan barcodes and all of that. We've got also a range of solutions on monitoring, vibrations, temperature, hygrometry, many things that we have mobilizing sensors on and that you can find on Orange IoT Marketplace. This may give you some ideas. And eventually, of course, we are connecting the products that come out of the factory so that you can do predictive maintenance when your goods are out there in the field and help improve your processes, or have your colleagues from marketing or from production know what's happening out there in the field.
Here we have an MDC Plus tool which is meant for manufacturing data collection. So it is part of Industry 4.0 also. There are also other aspects what can be considered when we are talking about Industry 4.0, but this system collects information from manufacturing machinery. The point is that if the machines are not up and running, they don't produce. And quite often you can hear when the CEO is having a speech that, okay, last year we made this well, but next year we will perform better, we do a little bit more work. So it will never happen. You have to do something else to get more profit from your company and from your manufacturing. So this is one way to get more profit by just using the information wisely. For example, with this system, you can know exactly what is happening in your production, and most importantly, if something is not happening, why the machines are standing still and not operating. This system is really easy to set up. It is really cost effective, and it is off-the-shelf solution for this problem. Also, well, data handling is one point of Industry 4.0, but we have been concentrating to the manufacturing. So by installing this type of tools to your production, you know exactly what happens in your factory, and you can base your decisions on real facts and not just to those what you feel that is happening in your factory. And by doing this, you can get over 20% more machine time without any extra costs. You don't have to invest in people, you don't have to invest on machinery, you just use what you got and you get more information from your manufacturing so that you can make more money out of your current equipment. One analyst from KPMG said that digitalization is not an option, it is a must if you want to be successful in nowadays environment of industry. So these are the tools which help you to make more money with same amount of people, same amount of machinery, and really cost effectively.
So what we're presenting here is Toyota's vision for the future of logistics, and we're working with Microsoft here to enable a concept, an idea for AGV deployment moving forward. One of the biggest issues for our customers today is the deployment time or implementation time for an automated solution, so AGVs into a warehouse environment. And the other perceived problem with automation is in lack of flexibility. So what we're doing is working with Microsoft to explore opportunities for the use of AI to help us with one, reducing the deployment time, and two, the increased flexibility once deployed. So what you can see behind me on this screen is an example of how we're using virtual reality and a virtual environment, a digital twin of a real environment, to train the AI to work in a logistics flow.
So what you see there is one of our pallet drones learning almost like a child in this digital twin of a customer's warehouse. So our idea, our concept, our vision is to be able to 3D scan a customer's warehouse, then make the digital twin, then deploy the AI for it to learn in an environment pretty much in the same way that a child would learn. Once it's deployed, it will continue to optimize within this virtual environment. And then once we've verified and we're happy with the quality of that AI, we can deploy it onto the vehicles immediately. So that means we can turn around something that would take a number of weeks to implement into a one-day deployment. And that's our goal, using both Microsoft products of IoT Edge and Microsoft Azure cloud platform.
Hello, my name is Miguel Arjona. I am a Research and Development Director of Alton Spain. I am going to introduce you our advanced manufacturing solutions. Just back to me, you can see a virtual factory that we have modeled. In this solution, we have connected most of the assets of the factory with IoT to analyze the data and develop predictive maintenance solutions. So, analyzing the data coming from the factory, we can say to the operators if the machines are going to fail, the life of the reeler, for example, and so on.
Hello, I'm Sven Schrecker. I'm the Vice President and Chief Architect for Cybersecurity at LHP Engineering Solutions, and I'm also the co-chair of the Industrial Internet Consortium's Security Working Group and the chair of the Automotive Security Task Group. And I'm here to tell you a little bit about the IIC today. IIC is the Industrial Internet Consortium. It is a collection of 250 some odd member companies ranging from the mega corporations all the way down to startups, including government, including educational institutions, so all collaboratively working on industrial internet. My focus is on security, and we work a lot with external groups to review standards and provide feedback, to work on thought leadership with other groups, for example, Industry 4.0, Platform Industry 4.0. The Security Working Group in IIC is working with the security team at Platform Industry 4.0 to work on thought leadership around trustworthy systems, around identity, a whole bunch of topics that are relevant and currently at the front end, the bleeding edge of industrial internet thought leadership. So we also do a lot around publications on security. We have best practices documents that we publish. We have a security framework that we publish. We have a privacy paper. We're looking at automotive security. We're looking at a whole bunch of different topics and providing publications on that. But then we take those publications and we actually make them real. We make them actionable. So we have a task group on security applicability. And this group is specifically tasked to take our publications and make them real. One way to do that is another group that we have, which is the test bed security team. So the IIC test beds allow you to take concepts with members of the security or of the IIC family and demonstrate capabilities within industrial internet. So we can have smart factories, secure cars, modern agriculture, whatever it may be. The test bed program actually allows you to demonstrate the technology in a real world setting. I'm here at IoT Solutions World Congress, and we actually have an automotive demo where we have a go-kart platform that has security implemented in some of the systems, and then we walk people through how to compromise the system and how the protected systems can resist attack, but the unprotected systems could be compromised immediately. So those are the kind of things that we do. Another group that we have works on trustworthiness. So from the IIC, we don't think that security is the be-all, end-all. We actually feel it's a mixture of the safety, the reliability, the resilience, the privacy, and the security, and that is actually the problem that needs to be solved, not just a security problem. For example, a very popular topic for Industry 4.0 and IIC collaboration is a smart factory. So we have a number of smart factory test beds already, and within those we can address security issues. So perimeter security, great. not especially effective. It's plus 1 point if you have it, minus 20 if you don't. So you need to do it, but there's not that much value in it because you need to have a layered security solution. So then we come into the communication security capabilities, the firewalls, the rules for filtering and authorization and authentication, etc. Within each device, we need to have some kind of a identity capability, which then enables the communication to do mutual authentication, authorization, traffic flow, encryption, etc. So it's really a layered approach, but it doesn't end with just the things in the factory and the communications within the factory. You need to have the ability to do security monitoring and security management. The monitoring tells you what's really happening in the smart factory environment, and then the management allows you to push out policy to react to it. Part of the management is also the updates, whether they're over the air or wired, it doesn't really matter, but the update process to keep the management under control. So there is a plethora of topics within the IIC related to security that we're working on, and we invite everybody to come out and join us and participate with us. So thank you very much.
Hello, my name is Lindsay Dyson. I'm with SAS. We're headquartered in Cary, North Carolina in the United States, and we're the leader in advanced analytics. And today in our booth at IoT Solutions World, we're actually showcasing our partner ecosystem. Whereas SAS is the leader in advanced analytics, we don't manufacture sensors, we don't manufacture gateways or routers. We actually focus on the analytics portion, and so we often depend on our ecosystem partners to enable our customers to have the entire IoT lifecycle. And so here today we have partners like Intel, we have Siemens, we have CGI, Advanced Information Management, we have Hewlett-Packard Enterprise, we have Cisco, we have Dell, GE Transportation. We have some really interesting pieces in the Siemens car that's showcased here. We're actually doing analytics on the edge. So we're actually taking the sensor data at the edge and we're actually predicting when the sensor would fail. It has nothing to do with the actual automation of the car, which is a very interesting use case. We also have Advanced Information Management, which is actually talking about cold chain logistics, getting wine from one space to the actual buyer, from the distributor to the buyer, and ensuring that the entire journey is we predict temperature, predict product failure, and things like that. So really interesting use cases. SAS itself, we have several solutions. One is event stream processing. Event stream processing, it allows us to do analytics on the edge at the spot of the source of the data. We also have a whole entire quality suite, which focuses on predictive analytics, predictive maintenance, asset performance, etc. And so that's our booth at IoT Solutions World. If you have any questions, please visit us at sas.com. Take care.
Hi there, my name is Johan Johnson. I'm CMO and co-founder of Crosser. We work with edge computing solutions for Industry 4.0 use cases in terms of putting advanced analytics, AI, machine learning and so forth really close to machines and assets inside your factory. What we see here in Barcelona today is a lot of companies providing great solutions for storage, cloud solutions, monitoring and so forth. And what we see that you as a customer are requiring are the ability to fetch legacy protocols. You want to run your solutions behind the firewall. You want on-premise solutions for your factories to do this analytics and gain insights about how your machines and your process is really working. Within edge computing, there are different kind of opportunities. You can run edge computing directly from a machine or from a gateway, or perhaps you can even run it from the cloud, and then it's called just streaming analytics. What we see today is that the big five are providing great cloud solutions, but sometimes it's very important to be able to do fast development and fast implementations of your protocols, and we see the need of ease of development. We see that you have difficulties finding programmers, but you have loads of great engineers, and that's something that we want to connect with. Therefore, we have built a flow build programming studio that is cloud-based, so that your engineers can build IoT flows themselves without any programming skills.